Good morning and welcome to 6th grade math.
Hi students, here's your warm-up problem. Find the greatest common factor and least common multiple of 24 and 60. Okay, so our strategy for both is the same. Make some lists and look at the ones in common. And then hunt down either the greatest or the least, depending on which one you're looking at. So let's start with the greatest common factor. First, 24 and 60, list all the factors of each number. Then you look and you go through and you circle all the ones they have in common. And then if at the end of that, you see that the largest one is 12. All right, greatest common factor is 12. Now let's repeat the process, but this time with multiples. So 24 and 60, we list out the multiples of 24, a few of them anyways. And then we do the same with 60. And hopefully, here we go. We have one in common. Now, you might be thinking to yourself, that's kind of intense and a lot could go wrong. I could, what if I miscount? What if I miss a factor? What if I, when I do repeat addition, listing all of the multiples, I make a mistake and then I'm off a number? Yeah, a lot of things could go wrong. And you might be wondering, is there a more efficient way? Well, good news. The reason why we're watching this video is because there is. We are going to be finding the greatest common factor and least common multiple using prime factorization. Probably a better way to say it is we're going to be building the greatest common factor and least common multiple using prime factorization. So prime factorization, we have factor trees. The nice thing about that is it's kind of fun and we're not making lists. We're just breaking the numbers down. So let's look at an example here. All right, here we go. Find the greatest common factor and least common multiple of 80 and 200. Notice the little bigger numbers, right? Who wants to list all of those factors and find all of those multiples? Well, you don't have to. So here's how the process works. Step one, use factor trees to find the prime factorization of two numbers. So if I were to go through and you find the factor trees, we break down 80 and 200 to the product of primes. Voila. Next, list the prime factorization of the two numbers in order next to each other. I like to put one on top of the other, like this, and you want to make it nice, neat, and organized, like so. All right. Now, what do we do with those lists? You circle the shared prime factors. Okay. Well, do they share a 2? Yes, 280 share a 1, 2. Do they share a second 2? Notice there's a 2 in 200. There's another 2 in 80. Yeah. Do they share a third 2? Yes, they do. There's another third 2 in each list. Do they share a fourth 2? I notice there's a fourth 2 down here in 80, but no, 200 doesn't have one. So we've got those. How about 5? Do they share 5? Yes, there's a 5 in each list. And notice that's it, because there's no matching 5 in 80, the prime factorization of 80, other than the first one. All right. So now we've got the shared factors identified, shared prime factors identified. Next, this is where it gets a little tricky. We are now going to use a Venn diagram to sort the prime factors. Remember, a Venn diagram looks like this. You use it quite a bit in English to compare two things, right? What do they have in common goes in the middle, and what's unique goes to the outside, right? So the two things we're going to be comparing is the number 80 and the number 200, specifically the prime factors of 80 and the prime factors of 200. Okay, so now how do I use it? Let's go back to our direction here. Shared factors in the middle. So notice, what do they share? They share a 2, They share 3 2s and a 5. So look at what I circled. There's 1 2 they have in common. There's a second 2 that they have in common. There's a third 2 they have in common. And there's a 5 that they have in common. Okay? Notice 200 has unique to it a second 5, and 80 has unique to it a fourth 2. So that's why those go into this column. All right, our work at this point, believe it or not, is pretty much done. No list other than this right here, but that's pretty tame compared to the list we just looked at. Well, what do I do now? How do I find the greatest common factor and the least common multiple? I just have to interpret what I have in front of me. So the interpretation, the greatest common factor is the product of the shared prime factors. In other words, everything in the middle here. All right, 2 times 2 times 2 times 5 gives you 40. Okay. And then the least common multiple is the product of all the factors in the Venn diagram. All right, so I already know the middle part is 40. Now I just have to multiply that by the 2 and the 5 on the outside, and that gives me 400. And you can double check. Yeah, 40 times 2 gives you 80, and 40 times, let's see, 40 times 5 gives you 200. So they actually are, 40 is a factor of each number. And 400, well, I just multiply the 80 by the 5, and I get 400. And the 200 times the 2, and I get 400 as well. So yeah, this works. All right, so once again, we use the factor trees to come up with the prime factorization. Then we listed the prime factorization, and then we circled the ones they had in common. We sorted the factors between shared and unique, and then we interpreted what we have. So there you go. And you might be thinking, well, Mr. Pavlotti, that's also a lot of work. Correct, it is, but you're going to see this actually, and this is going to be helpful in a lot of things moving forward in working with fractions and working with variables. This idea of breaking down things to its primes, while it is a lot of work, and it's strategic work, I'm not having to just randomly make lists ad nauseum. I'm going to be multiplying specific things together strategically to come directly to my answer, which is preferred typically.